today we're going to talk about scatter plots. A scatter plot has points that show the relationship between two sets of data. In other words, a scatter plot is a graph that relates two groups of data. And a lot of times you see them in dots, dots on a graph. Scatter plots are used to plot data points on the horizontal or x-axis and a vertical axis, which is also called the y-axis, in an effort to explain what extent one variable is affected by another variable. The relationship between the two variables is called their correlation. So we have several different correlations. We have a positive correlation. That's when the increase of value of one variable increases the value of the other variable. And this is an example of one. And you can see that as this increases, this is also increasing. And so it goes up in this manner. Kind of looks like a positive slope type situation. A negative correlation is when the increase in value of one decreases the value of the other variable. And so this one here is an example of a negative correlation. So as this number increases, this number is decreasing. And so then we get this downward motion. No correlation is when there are no linear dependency between the variables. And then it just looks like it could be positive, it could be a negative. We just don't know. It's a little bit of everything here. Then we have what we call a perfect correlation. And that's when they are functionally dependent. In this case, all the points are in a straight line. And so if I look at this one down here, I see that this is what they call a perfect correlation. It is positive, and it looks like if you connected it, it would make a straight line. A strong correlation when points are located closer in relation to one another on the line. And when you look here, see how they're kind of tightly grouped? These are spread, this one's spread way out from this one, but these are a little bit closer together. That's called a strong correlation. And a weak one is when they're located further apart in relation to one another on the line. And so you can see it on this one that this is a weak one because they're kind of spread out a little more. These, you can tell that they're fairly closely related. These are a little further spread apart. So that's called a weak correlation. Tomorrow we'll learn more about line of best fit. It is a straight line that represents a scatter plot, or the data on a scatter plot in the best way. This line may pass through all of the points, some of the points, or none of the points. A line of best fit is also known as a trend line, and we'll learn more about that in the next day or two. Okay. So a scatter plot is a graph with a numerical set of data pairs x and y. Correlation is a mutual relationship between the two or more things. And the line of best fit is a line on a scatter plot which can be drawn to model the trend line in a set of data. So we have here, we have positive correlation. So when the data points generally increase to the right, line of best fit will have a positive slope. So if I were to draw a line through this, it would have a positive slope to that line. A weak positive is when they're spread out a little more. Negative, same thing. When data points increase here, but they decrease coming this way, the data comes down. And this one's a fairly strong one because they are closely grouped together. The one next to it, this is more of a weak negative. It's still, you can tell it's trending down, but they're spread out a little further. No correlations when the data points are scattered about with no increase or decrease. You really can't draw a line of best fit in here. I mean, I could draw many of them, and we just can't find one that is the best fit. Okay? So the first thing we're going to do is we are going to create our plot. So we're going to draw the scatter plot of the data below, then tell whether the data shows a positive correlation, a negative correlation, or relatively no correlation. And you'll see that this has no title to it. There is no information here or here, and there's no numbering. So if I take a look up here, I see that my smallest number is 1 on the x-axis, and the largest would be 8. So I need to go 1 through 8 for the x. So 1, 2, 3, And then for my y's, looks like 8 is also my largest number on my y's. So I'm going to go up from 1 to 8. Just like that. And now I'm just going to plot my points. Okay, I have plotted my points. And now we have to decide, is there a positive correlation, a negative correlation, or a relatively no correlation? So when I'm looking at my points, I'm looking to see, does it look like as this is increasing, these are increasing, so is it going up in this direction? Is it a negative? Is it as this is increasing, this is decreasing? So as it's coming down? Or is it that there is no correlation where they are just too widely spread and we cannot tell? If you said no correlation, this is correct. This is a no correlation. Okay. So we're going to go to the next page, to number 3. It says you are a student manager of your high school soccer team. You are working on the team's program guide and have recorded the height and weight of the 11 starting players in the table below. And so this one's going to have much larger numbers. So we're going to be skip counting by how we lay out our graph. And it looks like our smallest number is going to be 66. And our largest number is going to be 76. Yeah, 76 for my x values. And then my y values, my lowest number would be 150. And my highest number would be 200. So that's how I'm going to number my graph. So I'm going to start with, actually I'm going to start with 60, going across. Well, if I did by tens, 10, 20, 30, 40, 50, 60, 80. Yeah, let's go across by 5s. So we're going to mark each one at 10. Okay, so I get it going across to 110. Okay, then I'm going to go up so that I go from 150 to 200. Oh, that one didn't work, so I'm going to start down a little lower. So I went back and I reordered how I started. So I have this one here starting at 150, going up to, then it's 160, and then it ends up with being 200 across the top. So now we're going to plot our points, and then we're going to try to determine what the correlation is. Okay, so now we have our dot plot, our plots put on there, and we need to determine what our correlation is. This is really hard to see when you are setting these up, but see how they are, as this number is increasing, they are increasing. This is actually what we would call a positive correlation. So it is positive. It is strong, because they are really tight together. Okay? It is not perfect. Now, something else I see is I have a cluster of points here. I have a cluster of points here. And then I've got this point up here all by itself. So this has two clusters. I think of clusters like a cluster of grapes. And then we have one outlier. This one up here, it's way away from everybody else. And so we have one outlier. That outlier is at 76,200. We can identify the location of it to know that it's separate from the others. And it's at a distance away from the last points. So that's why it's considered to be an outlier. Okay? And then tomorrow we'll talk about line of best fit.